Hi, Jack Summers here. So today I'm going to talk a little bit about our new higher current WheeStat potentiostat, right? So the old WheeStat looks a whole lot like the new WheeStat because they come in the same box, right? So um, this new one should have a ability to output plus or minus about 2 to 300 milliamps of current, whereas the old one was limited to about 6 or 7 milliamps. Okay, this one here you can see just from the physical shape of it. It's got these what is it called? Vent holes in the top. Bottom has vent holes too. Since the bottom has vent holes, we're going to drag the air through that, or we're going to perhaps let it diffuse through it, convection. And so we're going to need to put some little feet on there, right? So I got 4 of these little feet that should come in the box. I don't intend to glue them on there myself because that will, I believe that'll keep it from going into the size box I want to send. So trying to keep our costs down, that's the idea here. So a little bit of super glue. You got 4 little spots on the bottom. You can glue those things too. All right, so let's take a look here. All right, so the kit should come with your potentiostat. Should come with a 12 volt, 1 amp wall wart power source. 4 of these little feet, like I said, and one of these USB memory sticks with the software in it. We don't have the software all finished up yet, but when we do, that's what it'll look like. Little USB micro USB. All right, so we've had some trouble with people plugging in the USBs incorrectly, and I just want to point out that the USBs, this is not a USB-C, which is symmetric, so this has to go in with the 2 little prongs on the top, and if you try to put it in there incorrectly, you can break off the little USB micro socket, right? And you don't want to do that because that'll just mean you'd have to repair it. Okay, on this end of the potentiostat, you have the output wires for the electrodes, the electrode connections. Black is the working electrode, green is for the reference electrode, and red is for the auxiliary or counter electrode. This has attached to it a 20 ohm resistor. Okay, so a 20 ohm resistor is pretty small, and that's what we're going to use to test to make sure that we can push all the current through that we are saying we can push through it. All right, so we have, let's see, we have the USB connector, we have the power source, you plug that thing in like that, and on the other end you have a switch, okay? Switch has 3 positions, down does nothing, middle does nothing, up turns the power on, okay? That controls the power to the microcontroller as well as the amplifiers and such, okay? So there's no issue of having the power wrong. All right, so inside, so right now I don't have the screws in that hold it together so we can get inside of this. We have 3 different printed circuit boards, right? The microcontroller board is almost stock TIVA microcontroller board, evaluation board from Texas Instruments. I say it's almost stock because turns out you have to remove 2 little resistors to make this work. And I don't know, well, I do know why they did it. I asked the Texas Instruments people, and they said it was to make the things backwards compatible with other hardware. Okay. Anyway, you take those off, it's not going to hurt the microcontroller, and if you have questions about where those things are found, then let me know and I'll answer your questions. Okay, so we have the Texas Instruments board. We have our main amplifier board here in purple, and over here we have another board that has some amplifiers and some power generating stuff. Anyway, the electricity comes 12 volts in here. We have the ground coming off of it. Comes over to the switch. You turn the switch on and you start powering stuff. One of the things that you're powering is the fan over here. Okay, I'm not sure the fan is absolutely necessary. I guess time will tell, and we will see what we can do without the fan, right? Fan makes a lot of noise. If it gets on your nerves, then unplug the little JST connector there and just take the fan out. We'll see how that functions. Let's see. So we said you got to make sure you plug in the micro USB cord up, right side up. All right, I guess that's probably a lot more than you wanted to hear, but that's kind of what we got at this point. I'm going to be working on the software. Okay, so I'm going to go through some of the software for the Galvanostat. And let's see, I'm going to start with the user interface because that's what you're really interested in, I expect. And it's written in this thing called processing. I'm using version 3.5.4. When you open it up, you should see something with a whole bunch of different tabs. You shouldn't have to open it up, but I'm just showing you this anyway, right? So I have not yet compiled it I have not yet exported an app for it yet, but I'll do that. And when that happens, there'll be an exe app that all you have to do is double click on and it'll open, but we're not to that point right yet. So what I'm going to do is click on that button, and that's going to launch the program, which brings up the user interface. You'll notice there's a connect button up here, and it says connected on COM 8. Okay, let me turn the power off to the instrument, and if I hit that button, it'll say no responsive port. Right. So this when it wakes up should go looking for the instrument, and if it finds it, it'll give you something like this: connect on COM 8. There has been some issues connecting. I'm not sure what those are due to, and I hope to get those fixed, but I'm not going to guarantee it at this point. Anyway, now you're connected, right? We have a load file and a save file. I've got the save file working. The load file I haven't done anything on yet, but we'll get that. That's not something that's too difficult. Over here we have different modes that we can run. This is the first mode. It's called run to volts. If we hit the next button, it'll say cycle at volts. What this means is that it's going to start out at 0 volts. Well, run to volts starts at 0 volts and increases, ramping up the voltage until it gets to a set voltage. And that set voltage is down here, positive millivolts. Okay, so it doesn't have to be positive. It can be negative, but it's just the first voltage that it will try to achieve. All right, so there's also a limiting number of microamps. So this is set up to limit you to 1 milliamp, so 1,000 microamps. I suspect that's probably not what you're looking for, but if you want this changed to milliamps, I can do that, and we'll make that work. Okay. All right. So when you cycle, it says cycle at volts, and what the idea is here is I haven't set up this mode yet, but what I want to do is have it ramping up the voltage until it hits the specified voltage down here in positive millivolts, and then sit there for a time that is specified up here before going back to your 0 point and cycling again. And the number of cycles it's going to do is 10. It's the number you put up here, right? So 20 is a lot of time, so let's just back that off and say 2 seconds, and we'll change this one. You click in there, and we'll say 3 cycles. That's how these text boxes work, right? Okay, so the mode, there's a run to time mode that just will go and give you a single time sweep, and we have a cycle at time mode that I've been working on. Okay, so we're gonna demo that. Okay, so we have over here a place to put in a file name, and let's call this JSS underscore 11121. That's today's date, January 11, 21. You can put whatever in there you want. And okay, so let's collect some data. We're doing cycle at time, which means that you're going to go from this voltage, that's your voltage limit. It's going to cycle up to that. Well, it's going to be trying to get to 1 milliamp, and I don't believe it'll do that with the test resistor I have in there. Yeah, and it's going to be limited at 1.3 volts. After it spends 2 seconds on that step, it'll step to this other voltage with this limiting microamps. Okay, so we have a collect data, we have an end data, and we have a view button down. So let's just hit the collect data button, see what happens. All right, so we have this red line, and then it turned back to 0 and gave us a purple line, and now I believe we have a green line, and then it came up here, right? The first one was this red line, and we can make that go away by clicking on the file name. Okay, so when you click on that, it goes away. You click on it again, it comes back. When it's gone, it turns into this yellow text. You can make all of these things go away. Well, yeah, okay, they're all gone away now. Okay, and let's see here. This last part, what we're doing is the instrument is looking for the position where there is no current. Okay. And since what we have in the test cell, we just have the reference and auxiliary electrodes connected to each other, and then on the other side of a test resistor, we have the working electrode. Okay, and so since this is just an electrode thing, it should have 0 current pass at 0 volts. And if you look at the voltage over here, that's what you got. All right, so this is viewing the voltage, but we can also view the current. And down here you see there's a button and it says view current. And we're now viewing voltage. It says view current. If we click on the button, you'll see this is about 1300, which is where you told it to go, right? So we'll hit the view, and you'll see that this goes to 600 microamps. Right, we have about a 2 kilo ohm test resistor in there, and it's going to behave. It's going to give you Ohm's law behavior. Okay, you'll notice that the first run started at 0 volts and went up to your limiting 1.3 volts. Let's go back to voltage, right? So we're now in viewing current, and if we hit the button again, it'll change to view voltage. Now it says view current here. We're viewing the voltage. You'll see it says voltage in millivolts. When you hit the button again, it says current in microamps. We can change that to be milliamps if you'd like. Just let me know. Anyway, let's see, what were we doing? Back to voltage, right? Okay, so our first run, the one in red, you can see there's a red dot up here. It goes from 0 and up, right? The next time, well, what happens when it gets to its current limiting or voltage limiting situation, it makes a note, and it says next time you go through this cycle, start out at 90% of that value. Okay, so we're starting out at a higher current for subsequent steps. We're starting out a higher voltage and a higher current. Same thing at the bottom. In the red was the first run. It started out at 0 and it dropped down. When it hit its limiting value, it said, "Oh, that's about where we want to start next time, is 90% of that voltage there." Okay, so that's how things happen. All right, this last piece over here, that is where it's searching for 0 voltage. If we wanted to get rid of that segment or any other segment, we just click on the what is that called, the title, and we're going to hit the delete button, boom, and that one went away, and now we have, we're going from 0 to 4 instead of 0 to 6 or whatever it was, okay? We can select all files and delete them, and that's not going to work right for some reason. It just leaves this one on there. I need to figure that out, and I hope to get that done before I send it off to you, but you know, that's how it goes. Anyway, if you work it hard enough, you click again, do it again, then it's gone and there's nothing there. Let's see, what else do we need to know? Got the collect data, the end data, the view, the voltage and current. These are limiting voltage and current. File names. Oh man, I should have, you know what, let's collect the data again. I forgot to show you the saving files. Why is that? Okay, I need to fix that as well. All right, now we are starting to show our data. And when that one gets to the end, we'll be done collecting, right? I think we're done collecting. Are we done collecting? Yeah, I guess we are. I don't know what happened to that last little bit this time. Every time I look at this, I find something new. Anyway, if we wanted to save these scans, then everything that's not yellow is going to be saved when I do what I do up here. I hit save file. It's going to come up, and I guess it'll go into whatever whatever file I put this in. But let's call this test 011121. Okay, and we're going to hit the save button. Boom. And now we're going to do what we do. Okay, I'm going to open Excel, and I'm going to open it in Excel. It's a comma separated value file. What am I doing here? Open. And I want to, where the hell is the option of browsing? And you got to remember where you leave these things, and I believe it is in WheeStat. And we want to view all files instead of all Excel files. And then we want to find the file name we just gave it. File format's buggered up, but that's okay. It's something we can deal with, okay? So we need to say comma separated and finished. There we go. If we want to give these things some names, let's put a thing in there. We'll say this is millivolts. This one is microamps, right? So these are all separate experiments or separate time courses, so they don't have the same X values, right? So let's take a look at the first one. Going to have a scatter plot. And what the hell's wrong with this thing? That generally means there's some text at the bottom that is making life kind of crappy. Come on, all the way down. Let me just pull it down. Oh, what's that? All that null stuff. All right, there is clearly stuff I haven't quite figured out. But such is life. You know, that shouldn't be there. What is that? That is stuff left over from some other experiment, I figure. And I'll, if I know about these things, I will deal with them. I'm just going to delete, Come on, don't do that. Okay, we're just going to come over here, some random spot, and delete. And now we'll go back up to the top. And that is not what it should look like. It should be that this comes straight down to down. I don't know what's going on. Anyway, there's some sort of data problem. Well, it's not the data problem. It's a display problem. So right after, okay, so the blue is the voltage, the orange is the current, and let's see what another data set looks like. Let's see if this one looks better. Insert that one. Oh, that's just looking for the 0 volt, 0 current position. So let's delete that. All right, let's see what this one looks like. Insert. Okay. Why'd that only go to 2.5? Huh. Well, anyway, folks, we're going to figure this stuff out, and we'll get these things worked out. Why did that stop at 2.5? I don't know. Anyway, that is a demonstration of whatever it was I was demonstrating. Don't save. Okay, back to the user interface, if I can find it. Come on. All right, let's do that. There it is. Okay, there's our user interface. Anything else I want to show you here? So before too very long, I should be able to get the load files button working. I'll figure out what's going on funny with the save file. I bet if I didn't delete those earlier files, I bet there was something funny left over from those other files, and I don't know what it was. Anyway, it just screwed us up. Okay, so that is the user interface, how to use it, right? So let's close this thing up. When I send this to you, I'll send you the, let's see, we're at 16 minutes. I'll send you the what is it called? The source code and the source, and I'll tell you how to download the program that the source code uses. It's called processing, and you'll be able to edit it, right? It'll be a lot easier if you can edit it on your end based on, well, if you can compile it on your end. I'll help you with the editing, and then I can just send you text files, and you don't have to send me back send me anything that through the mail, anything physical to do updates, okay? All right, same with the, okay, all right, so this is the user interface. You also have to be concerned about the firmware, right? The firmware is the software that gets physically loaded onto the instrument, and it is called Galvanostat 12.7.2020, written in a program called Energia. Energia is awfully similar to Arduino, but it's for these Texas Instruments microcontrollers. And I recently recorded a video showing how to get Energia set up on a computer so that you can edit the firmware and load it onto the instrument. Okay, so the idea here is that if we have firmware changes we want to make after you have the instrument in hand, I can just do the troubleshooting, and we'll figure that out. Okay. All right. So what do I want you to see in the firmware? Okay. One thing that you should know is that you can go up here to Tools, and I believe COM port 8 is where we want to be. And then we can go into Serial Monitor, and we can run the instrument using the serial monitor. And this is a very good thing for troubleshooting. Okay, so to start out with, you give it an and symbol, an ampersand, it should come back with a star. What the hell happens here? Boom. No, maybe that's not it. Maybe a star and it comes back. There it is. If you give it a star, it'll send you back an ampersand, right? The and symbol. Okay, so there are a lot of things that you can do from here. One thing that we can do is we can set the sense resistors. Okay, so if we say R0, that's going to be a 20 ohm sense resistor. If we say R1, then it's a 100 ohm. If we say R2, then it's a 500 ohm. R3 is 2.5K. R4 is 10K. And these are going to affect the sensitivity of the instrument. Okay, and it'll help us in the future. We will be able to do troubleshooting if we know this. We can also enter P numbers, which have to do with gain. Okay, so a gain of 125. It says the potentiometer set to 2441 ohms. Okay, and down the line, this may be useful for something that we're not really going to go into now. All right, let's see now. We want to put R number 3, that's appropriate for this resistor, for this test resistor we have. And I think with a pot value of, what do I have it set to? Well, whatever it was, 125, I believe. Anyway, we can then input voltages. Let's say V200, okay? And I believe will tell the instrument to go to 2 volts actually, okay? So we input 2 volts and it measured 825 microamps, okay? So this is 2.012 volts is a measurement of the voltage output, and 825 microamps is the current output, okay? So you can measure the voltages using a voltmeter and compare it to what you're getting here, or what the computer is telling you, and you can do some troubleshooting in that way. Let's see, what else we need to know? We need to know that mode, M, you can specify the mode, you can put a comma, you can separate all these things with commas. Mode 3, and let's see, what is the next thing? L is for limit, which is voltage limit, and let's say 3000 millivolts. And what do we want? C is the number of cycles. We want to do 2 cycles. We want to have a time limit of 2 seconds, T2. These are all separated by commas. Comma's not, I'm not sure the comma is necessary, but whatever. When you have all that information, you need to specify the negative values. Let's say negative 3000, and these don't have to be negative, and minus 1000 for the current. Okay, so L is limiting voltage, N is the other limiting voltage. If you're doing one of these mode, is that mode 3? That might be mode 2. Let me think about this. No, I think that's right. That's right. Okay, final thing we're going to put in there is I for measure the current. Well, basically is run the freaking experiment, and we're going to give it the limiting current of 1000. Okay, so now when we hit the enter button, it's going to run the experiment that we just showed you earlier. Okay, and what we have here is we have time in milliseconds, we have voltage in millivolts, we have current in microamps, right? And we have these text lines in there that screw stuff up. Doesn't really screw it up, but it just makes it a pain in the butt because you got to go in and remove it if you're going to look at the file in, what's it called, in Excel, okay? So just to show you what we got here, just to bore you watching me screw around with this. You know what, that's enough. Okay, that's all the data. We're going to copy it. We're going to put it in Excel. Paste. We're going to go to Data, Text to Columns, comma, done. And we'll take a look at it. Let's see. Insert that. Okay, we missed something in there. Oh, man. Yeah, sometimes you got to do this more than once. Just because, see, this is where Excel didn't put the commas in there, so I don't, yeah. Let's see if we can just paste. There we, well, something's still wrong, but it's better than it was. And it's not a, it's something that with a little bit of patience you can figure out, because that's where the problem is, right there. Anytime there's any text in there, it'll screw you up. Hopefully that's the end of it. Yep. All right, so what we have is 2 runs that are overlaid, and it goes from the end back to 0, right? So that's what the data looks like, and that's how you get it. Anyway, I'm sure you're going to have questions, and I expect to help you answer them. I hope I can answer them, and we'll talk again. Okay. Thank you.